Hello everyone, I am Vishnu Priya. I am very much happy to welcome you all to Vidya Lakshmi YouTube channel. So in today's class we are going to learn about grade 12 physics subject, chapter 1 electric charges and fields. So in this chapter we will be learning about properties of electric charges and electric fields and its forms. Okay, let's begin the chapter now. The very first topic that we are going to learn is types of objects. Usually there are so many materials around us and the very basic part of each material is atom. So every atom is made up of proton, neutron and electron. Usually electron will be revolving around the nucleus and inside the nucleus we will have neutron and proton. Okay, so depending upon the number of proton and electron, we classify material as neutral object, positively charged object and negatively charged object. For a neutral object, the number of proton and electron will be equal. Usually, we represent the number of proton as the symbol plus and the number of electron as the symbol negative. So, here the number of proton and electron are equal. So, we say the object is a neutral object. The second category of object is a positively charged object, where this is a completely positively charged object. So, it does not have any electron. All the electron inside this atom is being lost. It has gone out. So, it is a completely positively charged object and it is represented by the plus symbol. And usually protons does not move out of the shell. Depending upon the movement of electron only we are going to classify any object as the positively charged object or the negatively charged object here. So here this plus symbol represents a hole, we can say. Before in this place an electron was placed but it has moved out, right? So that is creating an empty space or a void or a hole inside the atom. So that hole only we are going to mark it as a plus symbol or we are going to say as positive charge. So here in this positively charged object, all the electrons are lost, leaving away the empty space or void or holes here, which is marked by the plus symbol. Then the negatively charged object, it has not lost any amount of electron, it is possessing all the electrons inside itself and which is marked by the negative sign. So this is about the types of object. The next topic that we are going to see is the very basic properties of electric charges. So in general we know like charges repel each other and unlike charges attract each other. So here we have a depiction of it where in this thing we have two negative charges here. Both are like charges, right? So both like charges will be moving away from each other. So like charges will be repelling away each other. Instead of negative charge, if we would have had two positive charges here, then their cases also will be the same. Those two positive charges will be repelling away each other. Whereas in this case we can see a positive charge and a negative charge. Both are opposite charges or unlike charges which are attracting towards each other. So this is a very basic property of electric charge where like charges will be repelling away and unlike charges will be attracting each other. The next topic that we are going to learn is conductors and insulators. So the materials that are around us are broadly classified as conductors and insulators. We know what are conductors, right? Conductors will usually allow heat and electric current to pass through them. Most of the metals like copper and aluminium are examples of conductors. And insulators are nothing but the objects which does not allow heat and electric current to pass through them. Usually wood or mica or the plastic components are the examples of insulators. In practical situation we would have seen an electrician wearing a chappal or he will be working or standing on a wooden object, right? So why does he do that? Our body is like it is a conductor, so current can pass through our body. To overcome that he will be working over a wooden object. So that his body will not get affected directly. So wood and mica are the some of the example of insulator. We can see it using this circuit diagram. Here what I have done, I have taken a bulb, a cell, a key and two materials I have taken, one insulator and a metal I have considered. So in the first case what happens, electricity is defined as rate of flow of charges, right? So charge has to flow, only then electricity will be produced or it will be created. So now from the battery, usually from positive terminal to the negative terminal, flow of charge occurs. So here the charge is flowing, but after it reaches the block here, it is after it reaches the insulator, the flow of charge is blocked. So that's the reason the bulb here is not glowing. Whereas in this case, you can just look at this picture where the flow of charges is there. So electrons are moving from the cell and it is passing through the metal also. So a metal acting as a conductor allows the electrons to pass through them, and which leads the bulb to glow. So this is just the depiction of insulators and conductors where they are allowing the electricity to pass through them. The next topic that we are going to see is mode of charging a conductor. So there are two ways to charge a conductor. The first method is charging by conduction and the second method is charging by induction. So in this first case, charging by conduction method, the two surfaces are going to be in direct contact with each other. Whereas in the case of charging by induction, the objects will not be in direct contact with each other. Let's see how a conductor can be charged by these two methods. Firstly, charging by conduction. For this, I am going to take a neutral object. So we know already what is a neutral object, right? It will possess both positive charge and negative charge in it. So I am going to take a neutral object. So it has got equal number of positive charge and negative charge in it. Okay, at this I am going to place over a insulating stand. So the striped lines here mention the stand as the insulated stand. So I am going to name this as B. And next to it I am going to bring a positively charged conductor with an handle. So let's say this is a positively charged conductor and with an insulating handle. I am going to name this as A. When I say it is a positively charged conductor, what does that mean? It is in need of electron. So it has got deficiency of electron, it is in need of electron. So what happens here? The electrons present in the neutral object will be moving to A. So one electron from B moves to A so that it occupies the gap in A. So if one electron moves from B to A, what happens in B? A void is created in B. So for example, if this electron moves to A, then a void is created, which I am going to mark as a plus symbol. Similarly, another electron goes from B to A, creating a void here, but the void in A will be filled. So such that it becomes a positively charged here. So this process continues until all the voids in object conductor A is being filled. So finally we will be getting a completely positively charged object. So the final object we will be getting is object B would have been transformed into completely a positively charged object. So this is the method of charging an object by conduction. So in this method, the objects are in direct contact with each other. Because of that, electrons present in conductor B has been shifted to conductor A to complete or to fill the voids in present A. Always any object, either if it is positively charged or if it is negatively charged, it will try to attain a neutral state. So for that reason, when they are in direct contact with each other, the electrons present in B is moving to A and creating a void in B. So because of that reason, B has been converted into a charged object. So this is the first method. Second method is charging by induction. As I said previously, in this case, objects will not be in direct contact with each other. So once again, we are going to take a neutral object. So as I said, neutral object will possess both positive charge and negative charge in it. Okay. So this is how it looks. Now what I am going to I am going to bring a plastic rod which is negatively charged. We can make a plastic rod charged by rubbing it against a paper. So we would have played in our childhood by rubbing it against our oily hair or over a paper. If we rub, then it will be attracting small pieces of paper. Like if we place our hands near a television, our hair particles will feel some movement, right? And near a cotton or a silk fabric cloth, if we rub it against it, then we may feel certain amount of attraction there. So in those cases, plastic rods can also be charged. So here I am going to bring a negatively charged plastic rod. Okay, and it is connected to a insulating handle. So negatively charged plastic rod means that it has got excess amount of electrons. So electrons, what will it do? We have seen in the properties of charges, right? Unlike charges will be attracting each other and like charges will be repelling away each other. So this electron, this negative charge will be attracting all the positive charge towards it and repelling away the negative charges to the other side. So what happens here? All the positive charges will be moved to one side and all the negative charges will be moved to the other side. So we will be getting something like this. All the negative charges are moved towards one side and all the negative charges are repelled away to the other side. Then what we are going to do? We are going to earth this neutral object. So earthing is a process where the excess amount of electrons are moved towards the ground. Like to avoid lightning and all, a rod will be placed in our homes, right? So that rod is used to take away. Lightning is a process where clouds are being hit, where the electrons are being hit. So that's how lightning is created. So when lightning falls over any taller objects, if we place a metal rod which is earthed, then excess amount of electrons will be directly going to the ground without affecting our homes. So that is the usage of those rods. So earthing is a process where excess amount of electrons are grounded. It moves to the ground. So what I am going to do? I am going to earth this side of the object here. So this symbol is usually mentioned to say the earthing process. Okay, then all the negative electrons or excess electrons will be moving away. Then we will be left out with the positive charges over one side. And still this is existing on one side because of the presence of this negatively charged plastic rod. So this is how now the neutral object exists after being earthed. Now what I am going to do? I am going to remove this plastic rod. Once I remove this plastic rod, the positive charges existing in the object will be moved inside the sphere, like inside the atom, everywhere it will be located. So it is completely converted into a positively charged object. So these are the two methods of charging objects, charging by conduction and charging by induction. So the key point that we will have to remember is, in the process of conduction, the two objects will be in direct contact with each other. So A and B are in direct contact with each other. Whereas in this case, charging by induction, the objects are not in direct contact with each other. Drifting of charges are occurring. So here, positive charges are drifted towards the negatively charged plastic rod and negative charges are repelled away from the plastic rod. It is because of the very basic property of the charges, like charges will be repelling and unlike charges will be attracting. Okay, let's move on to the next topic. The next topic is basic properties of electric charges. So here we have four basic properties of electric charges. The first one is electric charge is a scalar quantity. There are two types of quantities, like as scalar quantity and vector quantity. Scalar quantity is a one which has only magnitude alone, whereas vector quantity will have both magnitude and direction. Here electric charge is just a scalar quantity, it has got only magnitude and it does not have any direction. The second property is electric charges are additive in nature. It means that charges can be added up. For example, in a system if you have n number of charges, in a system, if you are having n number of charges, say Q1, Q2, Q3 and Qn charges are existing inside a system, then the total amount of charges of that system will be the sum of each individual charges. So, we can mention it as Q will be equal to Q1 plus Q2 plus Q3 plus Qn. So, this is the understanding of the second property. Electric charges are additive in nature. So, the total charge of the system can be considered as Q, which is equal to Q1 plus Q2 plus Q3 plus Qn. Okay. Then the third property is charges are quantized in nature. So, when I say quantized in nature, we cannot have fraction of charges like 0.05 charges or 0.5 charges cannot exist. So, as a whole, either one charge or two charge, as a whole amount of charges only can exist. So, it can be written as Q is equal to plus or minus Ne, where N is nothing but the number. It can be 1, 2, 3, anything. And E is the charge, which is equal to minus 1.6 into 10 power minus 19 Coulomb. Okay. So, the third property is electric charges are quantized. When we say quantized, we say we can the whole number of charges only can exist. We cannot have fraction of charges. So, we can just use this formula to understand that charges are quantized. And the last property is electric charges are conserved. We would have learnt about conservation of linear momentum, conservation of masses, right? Conservation of energy. Likewise, this is about conservation of charge. As a whole in a system, electric charge can be transferred from one part of the system to another part, maybe due to any physical process. But as a whole, when you see, the net amount of charges will be the same. Before and after the physical process, the net amount of charges will be the same. So, that is about conservation of electric charge. So, these are the four basic properties of electric charges. The next topic that we will see is Coulomb's law of electrical force. Okay. So, Coulomb is a scientist who has given the relation between charges and electrostatic force. So, his statement goes like this way: the electrostatic force is directly proportional to the product of the charges and it is inversely proportional to the square of the distance between them. Okay. So, as per the statement, we can see the derivation part of the Coulomb's law. First, we can consider, let this be okay, let us consider charge Q1 and another charge Q2, where Q1 is the source charge. Source charge is nothing but the charge which produces the force, and point charge is nothing but which is going to experience the force. So, here Q1 is the source charge and Q2 is the point charge. So, and the distance we can represent as the position vector r. So, r vector is the distance between Q1 and Q2 charges. Now, as per the statement of Coulomb's law, we know the electrostatic force is going to be directly proportional to the product of the charges. So, we can just mention it. F is the electrostatic force, it is going to be directly proportional to the product of the charges Q1 and Q2. Let us have it as equation number 1. And then as per the statement, it is inversely proportional to square of the distance between them. Let this be equation number 2. Okay, now what I am going to do, I am going to combine these two equations to get F is proportional to Q1, Q2 by R square. Okay, so F is directly proportional to Q1, Q2 by R square. Then to remove this proportionality constant, I am going to introduce proportionality, I am going to introduce a constant K, where F is equal to K times Q1, Q2 by R square. So, this gives the magnitude of, let this be equation 3, This gives the magnitude of electrostatic force. Magnitude in the sense we can identify the value of the electrostatic force here. So, here K is a constant. So, it has got a value to be K is equal to 1 by 4 pi epsilon naught Newton meter square per Coulomb square, okay, where it is a K is a constant, right. So, 1 by 4 is a number, pi is a constant, epsilon naught is nothing but permittivity of free space. So, it is nothing but the amount of electric field that can pass through in a particular medium. So, that is the permittivity of free space, and that is also a constant value. So, epsilon naught is equal to 8.854 into 10 power minus 12 per Coulomb square per Newton per meter square, okay. So, when we substitute these values here, K is equal to 1 by 4 pi into 8.854 into 10 power minus 12, we get a value of K to be 9 into 10 power 9 Newton meter square per Coulomb square. So, this is the value of K. So, for a numerical you can directly use the formula of electrostatic force F is equal to 9 into 10 power 9 Q1 Q2 by R square, provided the medium is the free space. If epsilon naught is the free space, then it can be a medium also. So, then you can use this formula directly to calculate the force, and N is the SI unit, okay. So, magnitude we have identified. What about the direction? So, here vector force is a vector quantity. So, it should possess a direction. So, its direction is along the position vector r. So, Q1 is the source charge, it is only going to produce the force, and Q2 is the point charge which is going to experience the force. So, the direction of force will be along the vector r. So, we can just mention F vector is equal to K times Q1 Q2 by r square into r cap, where this r cap is representing the unit vector to represent the direction of the force. So, another way to represent a unit vector is a unit vector r cap can be represented as a vector by its magnitude, okay. So, this equation can be written in other form as F is equal to K into Q1 Q2 by r cube into r vector, okay. This is also another form to represent the electrostatic force mentioning its direction. So, this is about Coulomb's law of electrical force. So, what we have done here, the statement of Coulomb's law tells us that electrostatic force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So, what we have done here, we have considered two charges Q1 and Q2, and the position vector represents r, okay. Then as per the statement we have started our derivation. So, F is directly proportional to Q1 Q2 and it is inversely proportional to 1 by r square. I am combining the equations to write F is directly proportional to Q1 Q2 by r square. Then to remove the proportionality we have introduced a term K. So, F is equal to K times Q1 Q2 by r square, where K is just a constant. Its value is 1 by 4 pi epsilon naught and its SI unit is Newton meter square per Coulomb square, where epsilon naught is the permittivity of free space and its value is 8.854 into 10 power minus 12 Coulomb square per Newton per meter square. On substituting the values over here, we get the value of K to be 9 into 10 power 9 Newton meter square per Coulomb square. So, for a numerical purpose, we can directly use this formula 9 into 10 power 9 Q1 Q2 by r square. So, that is about the magnitude of the electrostatic force. When coming to the direction of the electrostatic force, it is always directed towards the position vector. So, we can just represent it as K Q1 Q2 by r square into r unit cap. R cap represents unit vector. So, a unit vector is also written as vector r divided by its magnitude. So, instead this equation can also be written as F is equal to K Q1 Q2 by r cube into r vector. So, this is about the Coulomb's laws of electrical force. In our next video, we shall continue with the next topics of electric charges and fields. Thank you all.